Welcome to Space Data Hackers. Today is October 30th, 2024. My name is Eric Veal, and tonight we are celebrating the NASA International Space Apps Challenge, which was last weekend in Seattle. And so just kind of a quick recap of what happened and some storytelling and fun that people had and learnings and lessons and victories and all the like. So that'll be coming up soon. I'm Eric on the right, and Mike Doyle's here with us tonight as well. Been hosting these events for the last little bit, and a lot, very fun way to learn and just be involved in this exciting industry. And just quickly about Space Data Hackers. Space Data Hackers is a community for people who love data in space. We explore data sets captured from space, share knowledge, and build skills for putting data to use to solve problems for our communities, businesses, and the world. We welcome all levels to join us. So we're thankful for you tonight and open discussion and talks from scheduled speakers about navigating these data sets, using machine learning, data analysis, and cloud computing to do all this, and then also diving into space data with Space Data Hackers. So that's us. And like I said, so tonight is kind of a recap of the Space App Seattle that happened just recently. A couple kind of promotional things here real quick is please find us here on meetup.com. Pretty easy Google search. Really, it's just meetup.com Space Data Hackers. Should be easy to find. That's where we post all of our events, and you can see past events there as well. And if you wanted to find out more about the broader organization here, so Space Data Hackers is a program within Space Northwest. There's the Space Northwest Alliance. Our membership program connects companies, academia, and individuals to collaborate in growing the space ecosystem in the Pacific Northwest. So there's the membership link, spacenorthwest.org/membership. Volunteer, always looking for additional volunteers. So please reach out to info@Space Northwest if you'd like to get more involved and figure out about events and just how to connect with the community, share your story and get more involved. Looking for marketing and social media people and skills, sponsorship kinds of things. If your company maybe wants to get involved in this sort of thing, anything planning related and organizational, very helpful for us. Space data mentors, anybody out there with knowledge they want to share, and then of course data analysis given our topic. And in the coming months, we definitely have a pretty big backlog of people we're trying to recruit into the next events, but nothing's decided yet for November, but that'll be announced soon. And then in December, just given the holidays and everything else, we're going to take that month off. And then this is our website for past events and so forth. If you want to go to spacedatahackers.com. And now I'm going to hand over to Mike Doyle, who will take it from here and recap us on last weekend.
Yeah, actually, I think it was a couple weekends ago. It was actually the weekend. Yeah, it was actually the weekend of October
Yeah,
4th,
sorry.
Yeah, time flies.
4th through the 6th. It has been a ride ever since then. And to be perfectly honest, the work didn't end at the day of the hackathon. Our judges went back into the projects, and we met during the week to select our global nominees. So what I'm really excited about tonight is that we've got a whole bunch of people who were on teams at the hackathon who can talk about their projects. We have a global nominee project here as well that can talk about what they did. Every project was interesting, and we had such good quality and such good engagement. And we also tonight, I'm really pleased to see that we have one of our judges, Marcia Drake, joining us, who can also chime in. And I think for tonight, we're really just going to be thinking about a kind of open format. I'll kind of kick off a little bit on what the weekend looked like and hand it over to the members of the teams to talk about their experiences, and what they would like to do next with space and data or with this community, and how we can support. But first, I want to see if I can share one of the projects that was at Space Apps this year. It was a video project that one person did as a solo. It was called Symphony of Light. It won our Art and Technology Award, local award. And it's a video that's just 2 minutes long. And I think it really kind of shares a bit of the feeling of what draws us to space, and what's really inspiring and exciting about Space Apps. So can everyone see the screen that I am sharing?
Yes, sir.
Yes? Okay.
It was good.
I'm gonna,
or the building blocks of life.
oops, sorry. We'll start at the beginning.
In the vast of space, hidden within swirling clouds of dust and gas, the cosmos performs its timeless dance. Here, stars are born, flames igniting the cold void of the universe, casting light that travels across the starscape. With this powerful eye, the James Webb Space Telescope ventures beyond the limits of human vision. From this distant vantage point, we peer into stellar nurseries, regions like NGC 3324, where the building blocks of life come together to form new suns. Within the swirling chaos of gas and dust, gravity pulls matter together, compressing it until, at a perfect moment, the star ignites. A brilliant new light emerges, its energy rippling outwards, illuminating the surrounding darkness. These stars, now burning in the depths of space, will one day join the billions of other galaxies, each one a vital thread in the tapestry of the cosmos. As we gaze upon the night sky, we are reminded that we too are made of stardust. The atoms that make up our bodies were born in the hearts of stars, traveling across the universe to form everything we know. In seeking the stars, we rediscover our place in the universe.
That's about it.
Awesome.
So that video was created by Juliana, who's one of the hackers. She was also on another team that oh gosh, Exospace. Am I remembering the name right?
Yeah,
But
sounds right.
she created that video using generative AI, a set of tools, and actually incorporated NASA data in the production of it. So I think it's one of these amazing examples of how space apps can really bring together a lot of different kinds of inspirations, creativity, use of data to do something that is truly different and can affect us in many different ways. I think the comment when she ran the video during the presentation was that, oh, I'm misting up, or, don't make me cry. It was very well received and very deserving of the Art and Technology Award. So in terms of just kind of running down what Space Apps looks like this year, built on the successes that we had last year, we were at the Mission Accelerator Center on the 33rd floor of the DocuSign building, a beautiful venue, and we're deeply thankful to our partners at the Mission Accelerator Center for providing the venue and all the logistics that went into that. We had more hackers than last year. I think we were up probably about 15%. And the amazing thing was that people came out and they stuck with it, even though the weather was gorgeous. Last year, I remember there was one team, a team of one person who just kind of like plowed through the weekend. He was expecting to have a team of his buddies coming in, and they saw that the weather was nice that weekend, and they decided to all go rock climbing or something like that. And but he persisted with his project all the way through. This time around, we were really pleasantly surprised that people came in, and more people came on Saturday, and people stuck it all the way through until Sunday. We had 12 teams, which is an uptick from last year as well. We had an amazing talk from Dottie Metcalf Lindenberger on Saturday. She was our NASA astronaut giving a talk. And very inspirational. And she was, one of the great things was that as an educator and a science fair kid, and someone who's also took a lot of teams to science fairs, Dottie was really interested and spent time with the hackers and learned about what they had going on. So fantastic from that perspective as well. So, sorry, and are people able to hear me?
Yeah,
Yes,
I can hear you
Okay.
fine.
Okay, cool. So, I guess I'll just kind of wrap up there and kind of throw it over to your way if you're up for it, Marcia, to provide any comments on on the projects that you saw and things that you liked about your first time serving as a Space Apps judge.
Sure, thank you. And I apologize if I get a little disruption behind me because it is Halloween and my son is setting up out in the back for the festivities tomorrow. But I will say it was just amazing. This is my first time judging, my first time being able to see many of these presentations, and I was in awe at how well the teams worked together, the amount of work that went into it. I know that these type of hackathons take a lot out of you, and there's a lot of mental exertion. I saw people camped out in the rooms. I think one group, I want to say they were calling it the dungeon is what I heard as they were working on everything. And yeah, I mean, the quality of everything that I saw just blew me away. And I'm very encouraged by everyone who's been working on the data. And I think what the future holds and where some of these projects will go.
Super.
Yeah.
So, Michael, do you want to talk a little bit about your project? Because GeoBrains was one of our global nominees.
Actually, Rahil, the team is going to be presenting. You are all probably very tired of hearing me talk. So, there he is. And Emily and Ellen and Cy. There's Helen. There's Cy. Thank you, guys. And let's see.
All right.
Ice.
Let me get the demo up. Okay. So our project was, is that screen sharing properly?
Yes, I see it fine.
Okay, great. So our project was like this 3D visualization where we're able to take like a particular section of terrain and then layer data on top of it, so that you'd be able to see it in 3D on top of the actual terrain, and it's all like transparent and nice and stuff. And so you can even layer like multiple data sets. And then the kind of big idea, like the interesting thing is that we have this option called cross map, where you can see it's kind of like a cross product of the other data sets that you have on there. So you can see like where the data sets are both high or are both low, depending on how you want to set it up. But so you can see kind of the cross map here. And in this case, unfortunately, it looks a lot like the population map, because our second data set is built off of like larger chunks. You can see like there's like flat planes instead of kind of more dynamic data like the population map. And also a lot of things just end up looking like a population map. So there's that. And then this demo is totally hosted online and publicly available if you scan the QR code, or I can also put a link to it in the chat. But this project was.
So there's another example in my background of transportation and ecology, basically. Sorry to interrupt. Go ahead.
Yeah, no worries. Yeah, so this one is population and then economic health disparity percentile is the blue graph. And then the cross map is kind of like we like normalized each of the data sets from 0 to 1, and then we took their cross product to generate the second map. So for all of us, except for Michael, this is our first time using any like GIS or anything like that. So it's like a really big learning experience for all of us. And we had no idea what we were getting into when we first showed up. Three of us were our students at UW, and then that's me, Helen, and Emily, and then we have another teammate, Sai, who I think is in the call. And he's in high school, I believe. And then I think our last teammate, Kevin, couldn't show up today. But he's a software engineer, I believe. So this was all of our first time using GIS. And actually on the first day, the team formation day, it was like our first time everyone meeting except for me and Emily. And we were just like standing by one of the posters, and Michael came over and was like, I have an idea for this poster, like for the challenge poster. And we were like, oh, yeah, we were just standing by this poster. We weren't sure we wanted to do this one, but Michael really sold us on his idea, and it ended up being a really awesome learning experience. And Michael actually said, like, we can just treat this hackathon as like a masterclass in learning GIS, but we ended up coming out with an actually really cool product that we're all pretty proud of, that actually kind of works, which we definitely didn't expect considering it's our first time using the technology. Yeah, I don't know. Emily, do you want to talk about it a little bit?
Yes. So on Friday, okay, we have like a timeline. So on Friday, we like had like a team formation, and we just like brainstorm ideas, and like we got a mentor, which is Michael, and then we researched like about other projects and stuff, and like our own project, the community GIS stuff. And then on Saturday, we had like crash course with Michael, where he was like explaining us all the GIS data and like QGIS and all the important stuff that we needed to like create a project. And then we also like learned how to render like the 3D maps or that is showing right now. And we also learned how to code it so that it renders the 3D maps. And then we also, Helen and I researched and found data for the map and the layering. So we did that. And we like set up the website on Saturday too. And then we finished up the website on Sunday, and like we had like debugging issues and took us like the whole day on Saturday to like figure out like how to render the map correctly. But yeah, we figured it out on Sunday. And then on Sunday we created like we added the QR code and like fixed up everything. So that was like our whole timeline, I guess.
Yeah, and one of the issues we ran into was like in QGIS you can like load in all of your different data sets, and then you have to like clip them, right? When we're like trying to render them, we don't want to render like the whole world's worth of data because the browser would explode and things would not be great. So we were like trying to clip it, and it was like, I think it was like 5 hours I spent on just trying to make the clipping work properly, and it ended up being a single checkbox that I just didn't like. I hadn't looked at one of the settings panes, and it was just one checkbox that was there the whole time that did exactly what we needed it to do, and I just not seen it, and so that was like 5 to 7 hours of my day there. I think that might actually have lasted 2 days. Like it might have been between Saturday and Sunday. It was quite the nightmare, but it all ended up working out in the end. So that was pretty cool.
So could I ask a question?
Yes,
Um,
absolutely.
So you guys kind of went from 0 to 100 on GIS over the weekend. What are your backgrounds that you think you brought to the table that made that successful?
So for me, I have like a little bit of experience in like full stack web development. So I think in terms of like getting the website up, I felt pretty confident I could figure that out given enough time. And I ended up, just in time getting it done. There's a couple times where I've put like a 3D model on a website before. But like in a totally different way than this. But I think that was like the main experience that I had that I could contribute. I don't know. Emily and Helen want to speak, and Sai want to speak to their own personal experience.
I have like experience with like also web development, but I didn't really touch the code or anything. I just touched the research and got the data. But I'm also taking GIS right now, so like this whole hackathon kind of helped with like my GIS skills.
I feel like I don't know if I had a lot of relevant experience coming into this, but like just knowing how to sort of research and find answers to the questions that you're looking for is just a good skill to have in general. So like watching a lot of YouTube tutorials and stuff.
I also didn't have any real background experience that would actually contribute to the product, but I mean, I learned a lot from Michael. He was a great mentor, but as in from my end, I don't think I brought anything to the table.
Yes, you did. You showed up.
I think
Actually, you did, because you actually made me slow down. Because I was getting wrapped up in my head in turning and burning, trying to get what I wanted done. And that I had a moment where I realized I had deviated from the fun aspect of it because I was kind of being irritable towards you. And so you just being there improved my experience just by sheer contrast, maintaining my attitude. So thank you.
Well, there we go.
No, that's fantastic. So I guess what would your comments be about how easy or difficult it was to find and then work with the data that you worked with?
I can speak to working with the data, but I didn't do so much of the finding. I think that was mostly Emily and Helen. In terms of working with the data, like it was my first time working with this kind of data. So I think in that regard, it was a little intimidating, but you know, Michael was like really patient and helpful the whole time. And once I kind of figured out the process, I think I could do it again. And I think it would be really fast if I was to do it again. And I was able to figure out, you know, like how things work because of yeah, all of Michael's guidance, and then also just spending all the time just interacting with the softwares. But yeah, I think it's not so bad once you know what you're doing, at least to get something like this out.
So I could speak a little bit to that. So some of the data I already had from 20 years ago. When the idea came from a class project I'd done when I went back to school to finish my bachelor's degree after a 20-year hiatus. And it was the first GIS class I took. So I had like the area of interest and the terrain map, etc. The grid, but the main data theme in this are these gridded data sets. So rather than dealing with polygons of multiple sizes and geometries and stuff, it's a raster image. It's a virtual terrain of like population or crop yield or whatever. And those are invaluable since a lot of your space imagery is already in raster format. It's relatively straightforward to superimpose whatever it is against the satellite information, which is you can project onto the terrain. And there's a lot more of these gridded data sets right off the, you know, out of the cupboard, so to speak, these days, especially from the ESA. There's this website called Urban Tep, TEP, and it has time series data, gridded data sets of all sort population, economic indicators and stuff that you can readily import into GIS to compare to your data. NASA seems to have orphaned the CDAC data set that we were using, which are built off the US Census. And I tried like heck to find a free and open source version of those, but lots of commercial stuff out there, gridded data sets, but nothing open source. So there may be a project just in even that, providing those. That's all I got about that.
Yeah, that makes me want to ask the question, Michael, to you and your group. Any thoughts of continuing this project and perhaps expanding it, put a few more filters on there? Because I think it could be a very powerful or even lucrative tool. And if you do some more data geared towards a certain industry or a few, but great job overall. Yeah, very, very impressive.
Actually, yes, it is a powerful tool. And actually, the original presentation as an undergrad, barely a junior when I went back to school, and it landed me a PhD. I was put on a research team to replace a PhD, and the National Science Foundation gave me a fellowship at full tuition, et cetera. So it is very, I put our little project on Nextdoor to my neighborhood, and I got an email from Nextdoor saying it had 1,600 views. So I live in the center of that area of interest, by the way. And so people really get it. It communicates to them very easily, especially the interaction part, because trying to put two separate maps together in your head, looking down from a God's eye view, is really a difficult thing to do. So yes, and it, like anything, this is the sharp point of the spear. Time, attention, and money resources is will dictate how fast it can expand out. Was that a good answer to your question?
Yeah, that's a great answer. And should we be calling you Dr. Patrick from now on?
No, actually, my fellowship ran out before I ended up finishing my master's degree. I'm a couple of credits short, and UW graduate school tuition is enormously expensive.
Mhm.
And I wouldn't take a loan out. My philosophy, student loans seem to be a racket. So
one of the things that's really cool is that there is a company called Dora Hacks, and they produce hackathons. They also have a community grant, like a micro grant program that you can apply for, that would provide some funding for your hackathon project to go on further.
right.
So that's something definitely to look into. Dora, like Dora the Explorer, dorahacks.io.
I could definitely see it becoming just a standard tool for government outreach and community groups and things like that. Especially if preparing the data set, like the digital terrain map is the Puget Sound LIDAR Commission consortium, who it's like 18 inches, some parts are 6 inches. That's a big data set. So it's entirely possible, though, to put together a pipeline, which, given this rectangle, go out, grab all these data sets, clip them, alter their resolution to what's needed, and then give the person a set of data that they can post on, like he did on his GitHub pages. In fact, you could probably just even post it to the GitHub pages for the person.
Cool. Other questions? Questions for the team?
I want to thank my team. You guys were awesome.
I think we have other people who are on the line who are on other teams.
Cool.
Would y'all like to share your experience?
Yeah, this is Brennan from the AgriOrbit team, the other global nominee. I responded to that email about presenting, but I didn't hear back. And so I was wondering, can I share a couple slides about what we did?
You can totally share slides.
Sure.
You should be able to have the power to do so.
Awesome. Okay, do you guys see these slides?
Yep, now we do.
Yeah, it looks good.
All right, sweet. Yeah, so our project was I was in that category for helping facilitate agricultural decision making for farmers using space-based data sources. And so what we created was a co-pilot to help farmers access that data and help them make decisions about how they farm. So kind of where that idea came from is that there's a number of issues in farming kind of related to access to technologies and pressures towards consolidation. So small farmers are being pushed out in favor of corporate farm consolidation, and then there's monopolization of farming technology by a handful of companies. And so part of what inspired that is my dad's side of my family is from northern Minnesota, kind of classic American story, immigrated here, homesteaded, and then had this farm. But we don't farm it anymore. And the person who does farm that land, he has to farm around 3,000 acres in order to make a living. And that 3,000 acres, that's not just his land. What that represents is his own family's land, but also the land of around 12 or so other families who either have had to, sell up and move out, or like mine, move to the coast, and got jobs as engineers and things, and now rented out to this person for less than the property taxes of that land. So yeah, this is the farm right here. My dog made it in every year, make a little road trip out there and bring the dogs to the farm. But so that's one side of that issue. The other side is climate change and having to do more with less, especially when it comes to water resources. And there has been so much promise in how you can use space-based data to help improve how you farm. So one of the things here is there's this NASA spin-off article that showed how farmers could cut their water usage in half when using data models that include things like evapotranspiration, which is essentially the water that is being evaporated out of the leaves and the top of the plants, which is kind of influenced by how the process by which the plant intakes water. So you combine that data with temperature data and wind data and various other sources, and use that to make decisions about when to water certain fields and operate at a more granular level for how you target your irrigation techniques throughout the season. And by using that data, up to 50% reduction in water. And that is an absolutely massive number, especially for very water intensive crops. But the issue is that data is not really accessible to farmers. Farming is sort of an expert in everything type of job. You have to know how to do so many things, but of course, the reality of that is no one can be an expert in everything. And so things end up falling by the wayside, and having to ask farmers to become an expert in how to interpret all these different data sources is a huge barrier to entry, especially in all sorts of other parts of the world. Here in the US, especially if you're a big corporate farm, you can access that data because you can go hire consultants that interpret it for you and help you make decisions. But how can we democratize that data, right? This data is already out there for free. So how can we make it accessible in a way that anyone can use it? And then how can we distribute that accessibility throughout the world? So the North Star for what we had looked at, kind of what we wanted to strive towards, is actually the automated weather reporting system. So, you tune to the radio. Of course, now there's also a website, and it gives you messages about what the weather's going to do. And that's such an incredible example of this complex set of data. It's multi-domain, but it includes space-based data. It's interpreted by experts, and it's turned into something that is highly valuable to a very broad set of people: farmers, mariners, pilots, all sorts of different groups. And it's incredibly accessible. It's almost maximally accessible. You just turn into a radio station, you go to a website, and anybody can understand, there's a storm coming, or this is what the temperature is going to be. So with this use case, we wouldn't be able to make something as useful as that or as accessible as that, but we wanted to try and strive towards that. And what we realized was the kind of best way that we can make it accessible with today's tools is to use generative AI and give that AI agent the ability to interpret this data and understand that data so that it can then work in communication with that farmer to help them make decisions. So we also now, present that on side of a map that does overlays, because it allows you to sort of interact with that data a little bit more deeply. But the entire app could just be that chat box. You can just chat with it. You can say, here's where my farm is. Here's the type of crops I'm growing. Here's my historical data about my farm. How do I make decisions on how much I should irrigate at this time of year? And then the system goes and looks at a set of NASA data sources. Can I move this little guy? Sorry, the tools are in the way of my tabs, but it's not that big of a deal. Here we go. So just to look at what we use, there's all these different constellations, and they're consolidated by this program. It's actually called the GIMS-GLAM, GIMMS-GLAM, which is my new favorite acronym. it's anyway, so they put it together. It's also in coordination with NASA Harvest. They help make this data accessible, so that you can then go and do things with it. And this was also the layout of our app was partially inspired by NASA Harvest tool they have, which essentially is a map overlay data visualization tool, which of course is very cool and accessible to data scientist types, but is not very accessible to farmers. So we essentially provide a similar tool that gives those overlays with this AI agent on top of it to help you access that data without having to understand, everything about how to interpret that data and still use it to make decisions. Yeah, I mean, that's sort of the gist. The whole idea there is, can we roll this out in a way that can provide a very specific impact, which is to help people be more efficient with their water usage, based on insights gained from space-based data sources. We have a whole lot of other ideas. Like one of the things that we think could be really powerful is this can interpret a human in the loop component. This was part of our original setup, but there's a lot of things kind of cut for scope in the hackathon. The idea being similar to how we have extension offices run out of universities in the United States. There's people like the Gates Foundation and other groups that have these regional experts positioned around the world. They could become an expert in how to interpret this space-based data. And similar to that automated weather system, they could interpret that data for their region. And then that expert analysis can be put into the context of the AI model so that anyone in that region interacting with it can have this sort of proxy of working directly with that expert without that scale problem of the expert not being able to meet with every single farmer within their region. And there's other pieces like the actual chatbot. We threw just a massive chunk of general farming knowledge because that could help with sort of a farming, education issues. There's a lot of problems, especially with these NGOs working in the developing world, trying to provide education, but it's very difficult to get that education where it needs to go and then do it at scale with limited resources. So you can throw all that in this chatbot, and it can sort of help out with that process. And yeah, we're interested in continuing this. One of the awards that we got was the best mission something, best like mission concept. Yeah. And to us, what that kind of shows is that there's, and we had a number of people telling us afterwards, like, hey, like you could probably put this in the hands of farmers right now. Of course, we can't right now. There's some work to be done, right? There's stuff from here to there, quite a bit. But it does really feel like something that could be useful. We know that NASA is interested in this because of all the funding they put into NASA Harvest. This kind of tool, this AI tool, could literally just be thrown on top of all of their existing interface that they developed for their tool. So we are interested in trying to meet people who can help us understand how to do that. Of course, another big piece is we need farmers, and we specifically need people who have an expertise in using space-based data for farming, because they can essentially dump a whole bunch of knowledge that then the AI can train on to understand and better communicate that. Yeah, that's sort of it. Our team expertise, I think pretty much everyone on the team was a software engineer of some sort, and we had one a university student. And so that, a number of us had quite a bit of experience with very quickly throwing together things that just barely work enough to be evaluated. And so that really helped us. And then a number of us have had a good bit of experience with using, creating AI agents and using generative AI, web development, things like that. Oh, and I guess this little thing on the side here, it's kind of just a GIF, but definitely should have had a demo fully working. It's called Space Data Hackers, and it didn't occur to me that like that would be the hackers component. Everyone would want to see that. But essentially, it's just showing how you can indicate your location within the user interface. You can manually select and view which products, which essentially constellation data sets you're using. But then you can communicate with the AI, and it has basic things like suggestions that you can click through to more easily use it. But essentially you say, here's where I am, and you say, this is what I need help with. And it goes and figures out what data it needs to pull to answer that question. And then, semantically compresses that data into something that can be used within the model's context, and then provides a response based on that. yeah.
So I have not a question per se, but one of the places I grew up was Grand Forks, North Dakota. My best friend was a wheat farmer, or his dad was a wheat farmer, and we spent a lot of time out there. So I appreciate how difficult the business is, and just some, fusion of what we do here at Space Northwest and Space Data Hackers is last year our entry was a fire warning system using the NASA firm's data that would deliver warning messages to a flip phone, text only. It'd leave you a voicemail message. Okay, this is happening this far away at this angle. So that kind of low-tech communication thing is ideal for a place like Africa, where 85% of the phones are not smartphones. They're low power usage flip phones and feature phones. So that might be useful. The one we showed today can go down in scale. So if you have the soil types from soil grids, and the USDA also has soil maps of a given area, the different factors that go into your growing paradigm, every farmer has their own, which show where those interactions are occurring. The submit, and then from a couple of hackathons ago, actually the first one that we were given a global nominee for was about weather, and part of that was a proposal for a weather bot to give, precise, very localized information about your particular place, pulling data from the National Weather Service and the big climate supercomputer farm in Wyoming. And the one thing that has happened right now is, and this, not that I don't like AI or whatever, there's a vast amount of low-hanging fruit just even being able to see the data. And for instance of that is the USGS, the US Geological Survey, is wrapping up their 3D elevation program, and they have done the entire United States, a terrain map to about a 6-inch to 1.5-foot resolution over the entire country. But not only the terrain map, but the surface map. So the vegetation and stuff is sticking up. And then also the LiDAR point clouds are available that the data was derived from. So for any given field or whatever, all of a sudden we have a lot of really, really good data, about the lay of the land. And most people, when they look at a field, they think of it as this flat, monochromatic thing. It is not. Even if the elevation differences are only 3 inches, it severely affects the movement of equipment, the crop cycle, the moisture levels in the soil, etc. And those data, the new data sets, are so accurate. I was looking at a farm along the Powder River in Wyoming, and I thought I had artifacts because I had these weird things happening in the image. And I zoomed in, and I finally figured it out. It was detecting when fields are worked over time, the tractors compact the earth under their tires. So certain places, get worn more than others. And it was detecting elevation differences, probably less than 3/4 of an inch. So there's an explosion of that sort of data that's happening right now. And just being able to see that might be sufficient. And then that's the launch point. Watching how the farmer uses that data helps form the algorithms that might be useful for everybody to use. So I just thought I'd mention that. If you'd like to talk about any of those, please.
Could you send the USGS data you were talking? I've been playing with point cloud data for a little bit. It's this quarter at least. And so I'd be curious to take a look at that actually.
Yeah, I'll post it here in the chat.
Yeah, that the precision farming stuff is pretty wild, kind of to the level it's at. I didn't know that they actually produced a whole national map, but I worked on something somewhat recently about being able to create like automated 3D models of buildings for first responders, kind of as they're like arriving to incidents and things. And there's a lot of difficulty with that. One of the things with the precision agriculture is to kind of illustrate how kind of targeted and precise it is it's now down to individual plants. I mean, there's technology called See and Spray, which as an implement for fertilizing and irrigating the crops is moving over a plant. It is using computer vision to look at each individual plant and determining what or whether or not to and how much fertilizer to spray on that individual plant. And it's pretty wild. But one of the big kind of pressures with that is all of these marginal gains create a pressure on farmers that move it towards land consolidation. And what I mean by that is if that technology costs, say, $500,000 to obtain, then it gives you let's say a 5 or 10% increase in yields, and that's an extra $5 an acre. Then to make that money back in a year, you'd have to farm 100,000 acres. And to make that money back, in 10 years, you'd have to farm 10,000 acres. And what that means is that only people who have the means, the massive, massive farms, can buy that technology and use it and get that gains and then produce more crop, which then slightly drives down crop prices. So then all of the other farmers who aren't able to obtain that technology and get the increased yields are now making less per acre. And so all of these, it's a weird area where at this point, innovation has been so a big part of it is because it's monopolized, because essentially John Deere can charge whatever price they want for that technology. But it means that the big players just keep swallowing up all of the small farmers, even though our yields are increasing. But we're actually also at a point where we have massive, massive tracts of land that are just laying fallow every year because we can produce so much more than we need. So we don't even necessarily need increased yields to an extent. And so that's why things like this is something already done today, right? Using all these space-based data sources to improve crop yields is already done. It's just behind this paywall. And so that's why having something like this that can make it open source and doing that with other technologies, like there are people making, open source tractors, right? Especially in the wake of companies like John Deere now removing kind of that right to repair and things like that. And of course, that open source tractor is probably never going to be as good as the John Deere tractor, right?
It doesn't have to be.
Yeah, it doesn't have to be. It just has to be good enough, right? It has to cross a barrier of being useful. And something like this being open source, it's already free data, or rather data that our tax money is already paying for, coming from NASA. And if you can provide this in an open source manner, the only cost here is the inference costs of running the AI that is helping to interpret it. And that's coming down and is pretty low. And the reality is, a farmer could probably use this all year to support them, and it might cost 10 or 20 bucks worth of that inference. That is significantly less than the tens of thousands it may cost in order to have consultants that are helping you throughout the year to perform this. So hopefully things like this could make it out there and actually provide value.
So back when I was in school, I actually went in my business GIS class. I had a proposal for kind of GIS storefronts in these small towns, basically along with the extension offices, which are remarkable, right? Those are like a primary consultant thing. The delivery chain of making people aware of it, et cetera, compared to most software products and markets, is actually fairly easy to figure out and deliver to, and would probably be greeted with a lot of enthusiasm, especially among the small farmers.
I guess my question is, all right, if there's demand there, right? Is there a market? Is there a business to be made? And Space Data Hackers kind of exists to help with that community that takes your idea and supports it as it grows and it becomes whatever it's going to be, whether that's a business or a nonprofit or something else, right? What are your thoughts on that?
I think there's so we know that there is a market for for these solutions because we know that there are companies. In fact, that this article, right, it's about a startup this is from 2020 who is created a model that this tool technology is what it's called. I haven't looked them up yet. I haven't actually done like any comprehensive market research on this yet. But we can know just kind of straight off that there is a market for providing this. I imagine that the cost to obtain this right now from existing solutions is pretty high. And one of the advantages of having an open source solution sort of as the backbone for it is it can bring that cost down. And so there could be a market of making this easier to access. One way of at a lower cost point, I think could be a market. But I think a big piece is making this easier to access by utilizing that AI component. So instead of it being you as a farmer have to sort of figure out how to interpret all of this space-based data and then obtain it from a company that is providing some value add to it, of course. That might be a different customer than someone who just wants to be able to talk to something like a chatbot and have this text-based conversation and then get a map of their field saying, based on your strategy of stressing the crops by this amount at this time of the growing season, you can increase, we see high evapotranspiration in this field, so you can decrease the watering, and this other field we see low, you need to, increase it, whatever it is. That might be a different market. I think there's also a potential market with that NGO angle, if this is being used to facilitate their broader goals. So one of the ways, I guess, of looking at this is in the US, this could help smaller farmers stay more competitive with big ag. In parts of especially the developing world, this could potentially, and tools like this could help a farmer go from not providing enough food for their community to providing a surplus in food, right? If they're water limited, reducing the amount of water they need for their crops means if they use the same amount of water, they could potentially grow more crop. And now all of a sudden they're producing a surplus, and that has an economic effect on their family and reinvestment back in their community, all of that. So we think there's an angle on that side, and also potentially on the government contracting side. NASA already has money and programs going to providing more access to space-based data for farming. That was what was behind the sponsorship of this topic. It was NASA Harvest, and I can't remember the name of the other program that was involved. So we see there's multiple angles for it, both on, there's the commercial side, there's that NGO side, and then there's the government contracting side. That could all be potential pathways to market.
So I see there's kind of a generic difficulty dealing with the farming community. They're incredibly busy, under pressure all of the time. And so the loop back to the benefit needs to be fairly tight or extremely obvious. And it needs to be expressed in units that farmers understand. The biggest thing is always, how does it affect my yield? And that's the return on investment of time and money or whatever. If it is fairly obvious that it will be a dramatic increase, it's a no-brainer. But something that's like generically beneficial or whatever is a hard thing. So you'd have to make, and in the beginning, I'd focus on one particular type of crop, which is like, very favorable to all of the data, resolution to get started, not try to be all things to all farmers, but maybe that's soybeans, because the way soybeans grow, the signature of that changes very dramatically during the season, right? So you're not trying to parse out individual, very small differences with a lot of noise. Anyway, that's my 2 bits on.
Yeah, and so actually in that spinoff article, that company focused on vineyards and I believe almonds were the initial things they were going for, which, orchard type crops, it's static, but they're also very, very high water consumption crops, almonds being the highest of all crops in the country. So it was also the greatest opportunity for impact. So, that number of reduced water consumption by 50%, that could be applicable to, just not having the drip lines on 24/7 on your almond trees and knowing when to turn them off, you're going to get that number. But say with wheat, you're probably not going to get a 50% change. What we have looked at and are strongly considering is doing something, trying to go for something like a USDA SIBR. So just for those unfamiliar, it's Small Business Innovation Research Grants. USDA has a program for it. I haven't actually ever applied for one with USDA, but I know that there's a pathway to do that, because that would give us that funding to really go and prove that there can be an impact, and then leave that program with that evidence and then go directly to farmers with it. But yeah, there's in order to get, well, actually, we don't necessarily need to do any more development in order to win a grant with the USDA. We just need to go and sort of understand that and maybe do more business development. But yeah, there's also, if we could find a way to get some sort of gap funding, or just some way of allowing us to focus some more time into this and proving out some of the concepts in it, I think that would put us in a position to be able to do that. Because it'll be a really large commitment to actually realize this.
Are you located in the Seattle area, or where are you at?
Yeah.
Right. So obviously the problem on our side of the mountains is the frigging clouds. But ideally, if you hopped across the mountains in a small town like say Wilby or whatever, go in the bar and start buying rounds of drinks and start talking to the farmers, and you'll have a bunch of people that'll want to be a test case and get your feedback immediately.
It's another funny side note as well. I like how you brought up the John Deere example earlier. Work in government purchasing and around the circles in our industry. We do not like John Deere. We do not like the tractors at all. But I just want to say, great job, guys. And when I saw your presentation, I was blown away. I thought it was, I'll just say it was extremely, extremely well done. And you had a great team leader as well. So Michael Jong was there last year, and he's also a global nominee. So whatever mentorship he gave, he's doing something right. So I hope you all return next year and see what you do. In fact, I hope everybody on the call returns next year and brings back some more impressive projects. Great job, guys.
Yeah, thanks. And that was well, you can thank we can thank Eric for the good pitch, because I actually had I went to a bike ride in the morning. I was originally it was Eric and I were both gonna pitch, but then there was this the Kitsap Classic is through Cascade Cycle Club. And so I went to do that in the morning, and then had to book it, and then like basically arrive in the door. And for a minute we were thinking that like, oh, like I'll just like walk out the elevator and then we'll pitch, because we were second to go. But then Eric was like, okay, like no, I'll just do the.
He was a little late.
Yeah, Eric's like, no, I'll just do the pitch. So he basically wrote, and so we won the best storytelling award because of the story he told. So that's pretty good.
Yeah, I appreciate it.
Yeah, I was telling Mike Patrick earlier, I think both of your projects has a good chance of doing pretty good in global, and in global nominees. So looking forward to hearing back from that.
We don't even know how to like assess or have a basic understanding of that, because there's like 940 global nominees. It's such a huge it's hard to understand what they're looking for. But looking at the winners from last year, it was kind of, I was almost expecting to see things that were like almost like finished products coming into the hackathon, because that's how this often goes with a lot of other, especially startup related hackathons.
Exactly.
But they were all very much like things that were done in the weekend, and there was definitely that vibe with all those projects. And so we're hopeful, but don't know how to assess us being a couple teams out of 943.
Definitely.
I think from my general hackathon experience, I was in a 3-way tie once with the judges, and they decided after like 3 hours of discussion, they did it by a flip of the coin. So probably quite possible in the end, when they're down to 50 or 60, that they just use a random number generator. I mean, how else could you do it? I mean,
yeah. Again, I think that these projects are both great and have legs for you know, advancing, and we'll see. You know, the NASA criteria are what they are, right? And that's what we shared over the weekend. And it all comes down to, you know, who's judging and what the field looks like at that time. But you know, I am probably more excited about the possibilities of what you've got, what you've been able to achieve, and where it can go well beyond global judging, right? You know, I know that there's a lot of projects that, you know, didn't even get an award, but they were amazing projects at Space App Seattle this year. And so I'm, you know, all about what you guys do next. So thankful that you came out to be a part of this, and hope that it helps you along on the way. And by all means, you know, just like shout out, hey, you know, we could use help with XYZ. I heard you say the gap funding. Check out Dora Hacks. There might be something there. Our community includes people who've done lots of SIBRs, and we could probably help you hook up with some of those folks. Maybe not USDA SIBRs, but maybe.
I put my name and email address in the chat if anybody wants to talk further.
Michael, actually, a quick question. Do you know any data sets about the yields? You were mentioning the yields across the US. That would be like the most important thing for farmers to track, because it spawned an idea. I had done some work in vertical farms, and there's this research paper out of MIT on climate recipes, where with greenhouses, you can modify like nutrient profiles, light profiles, even the frequency bandwidths. And with the goal of maybe we'll find out what the loss gradient looks like for farming and optimize the best climate recipe to grow within a greenhouse. And so they've done a lot of research that way. But if there's like a data set that shows yields across the United States or in general, that would make that kind of research or that kind of exploration a lot more straightforward.
So the original Earth remote sensing system was Landsat, which was specifically built for agriculture. That's why the pixels are as large as, or the size they are, because they're 1 furlong by 1 furlong.
Mm-hmm.
So,
is there any particular that you'd recommend?
Well, I would have to go look. It is an ocean of statistics. I can tell you how many wolves and coyotes were killed in Montana this year by what kind of trapping. Some of it it's odd because of it's semi-secret. In other words, the USDA has a registration program. It's confidential, you know, because you're competing against other farmers. It is a business sort of thing. And so it's sometimes variable what is available at what resolution in what areas of the country, because the individual senators and representatives, you know, write their own rules sometimes with these federal agencies. But I could take a quick, you know, tonight I'll take a quick scan. If you send me an email to remind me, I'll see what's out there.
Sweet.
Yeah, Eric, I think precision yield data for crops, I think, is incredibly unlikely to exist. It's collected, right? So as a combine is harvesting that crop, it's actually collected. I don't know what the standard cell size is now for like John Deere's, you know, system. But let's just pretend it's like, you know, the width of a combine is, you know, 9 meters wide by a meter or two in depth, right? They're collecting yield data as the crop is being separated inside the combine. And so that is precision yield data that the farmer has. that John Deere may or may not be sending back to their servers. So they're probably collecting a data set there, but that's where it exists, right? It exists on the computer on that combine. And unless they're compelled in some way to send that data, it's probably not going anywhere that's accessible.
Yeah, I expected as much because like in a closed operation, like with vertical farming, we just weighed the harvest trays to figure out how we like what our yield was.
And this is generic, not just directed towards agriculture, is people tend to think that more resolution is better. It's sometimes not. It's highly dependent on matched to the phenomena of the system that you're monitoring. And if you go as far as you can, whatever, you just get noise. And so there's some advantage to the field level, the plot level, the row level, etc., that gives you good enough information to make the sorts of, decisions, because that's how the farmer is applying. They're not sending out 1/4 of a pickup of fertilizer to hit a certain spot. They're gonna keep the same application or drop the hoe same depth, maybe vary it a little bit. So you don't necessarily need hyper precise. We scientists would like that because we think more is better, but the reality is and the Defense Department also has published a lot about that, like, because resolution costs money.
So one other thing I was curious about, guys, and do you ever think about, if you do continue this project, actually taking up Michael Patrick's advice and going out and actually reaching out to a small farm and put this to a use case? Because I think it could be very much needed.
Yeah, well, I mean, I'm thinking of taking it to the guy who farms our farm.
Exactly.
just talking to him as a starting point, right? Or even just not even necessarily to like have people put their hands on it, but just to have those conversations about like, do you use this data already? If you had access to it, how do you think you would use it? And just that kind of basic stuff. And then eventually, and kind of normal customer discovery. So we've been thinking about doing that, right? Going out, can we talk to 100 farmers and then have a list of 100 people that we would then try it out with when we have something working.
Yeah, could be a good win-win.
So if you're not a data geek specifically, if you can get in Google's My Maps and draw the polygons of interest of that farm in Minnesota, like that you want data on, and send those to me, I'd be happy to take a look-see through the various portals and see what I can get you, already trimmed to, support that interrogation.
Okay, that could be interesting.
Do we have any other teams represented on the line? Anyone who hasn't gone yet?
I think we've been bleeding participants since we started talking too specifically about farming data.
Yeah.
I've seen the number going down.
Whoops.
Well, hey, I mean, as is rightly pointed out, there's a long history with NASA and agriculture. And in fact, in the first hackathon, the Space Apps Challenge in 2015 that I went to, the winning team was a machine learning project that looked at the metadata about the data that NASA had, and correctly derived its tagging, because at that point all the tagging was done by humans. And if you looked at just the metadata, you would think that NASA was an extension of the Department of Agriculture, because the number one tag on the data sets was agriculture. That project actually was one of the most successful, because NASA actually did work with the team to incorporate it into their strategy around data management and governance. And I don't think like that specific thing is currently in use, but it became the basis for what came later.
Yeah, I imagine machine learning models to tag their data is just like the common practice in everything they're doing now. So
Oh, and I was also I know it's more farm stuff, but synthetic aperture radar from Sentinel, that's a whole new area because when that dielectric of because of the soil moisture and vegetation, that's a whole very new wealth of data. So you'd be first dog to the bone with that. I'll shut up now.
Okay. Is there anyone who hasn't had a chance to talk who would like to share their experience at the hackathon or thoughts about what comes next? Things that you wish space data hackers would do for you to continue your journey in space and or with data. Aim.
Good evening. Thank you so much for letting me speak. I just want to say that it was a lovely event. I enjoyed it so much. I enjoyed speaking to professionals in the field that I wouldn't have a chance to speak to otherwise. I just want to say maybe it would have been nice if we did connect on Discord. Yeah, we have like a community and we ask questions over there. It's really nice. It's kind of cozy as well. But I just wanted to say it would have been nice maybe if we had to like we could create a community as you did similar. So you know how people or kind of people who have completed the NASA Space Apps Challenge are coming back, returning as volunteers or as mentors. So I feel like it would have been nice if we could also create a community like that for the people who have participated in this challenge so that we could reconnect on, do some projects together as well with other teams or similar. It was really nice to connect with people. That's all I wanted to say. Thank you.
Yeah, thanks so much for that. We did spin up a Space Data Hackers Slack channel that was kind of intended as a place for that kind of discussion. It never really caught fire, but I could definitely see how we could, with the context that you're kind of suggesting here, like almost like a Space Apps alum,
Yeah, similar. Yeah.
place where people can continue to hang out. Maybe it is the Discord that we've got and just a separate channel for alums, because we have been we have maintained this over the past couple of years. And it seems that people like Discord for their fun stuff, and Slack just feels like work. So
you may have noticed I answered questions off of Discord long after the event. So
yeah,
that capability actually is there. Maybe a little frosting of organization needs to happen, but it's a good idea.
Okay, thank you. Sounds great. Yeah.
Thank you. Anyone else? Okay. Well, I can say that I had a blast. It was a great session. This was a great session. It's, like as an organizer, as somebody who sees everything come together at the end, and then everybody gets like 4 minutes to present their project, and then like maybe a minute of question, and maybe you get a little bit more, maybe. Having this evening where we could dig in more depth, get to know the projects, and celebrate all the amazing things that you guys were able to accomplish over the weekend, and what Space Apps is all about. Really looking forward to what we'll be able to do next year, and so glad to have you on the journey, and definitely always there to support your journey as you go on to do great things.
So AM?
Yes.
So my Discord ID is underneath in the introductions on the Discord channel of the event. Feel free to connect with me, send me a direct message so I know who you are, not just by your varying username, et cetera, et cetera. And I'm happy to engage with you. And I know other people that would also. So you could be the seed of that effort.
I would love to. Yeah, sounds great. Thank you.
All right, all. We'll wrap it up for tonight. Hope you'll join us for our November edition. We'll keep you posted on what that one will be all about. And until then, enjoy the rest of your month and have a great Halloween if that's something you're into.
Sweet. Thanks, Michael.
Oh,
Take care.